So in the last video, we were looking at the user cohort embeddings.py, or the cohort affinity approach of learning how to represent the user without being specific to that user ID. And the last thing we talked about is adding softmax layer after the cohort addressing to ensure that the output is like a probability. And we have gone ahead and done that here. So I've updated the diagram as well. Hang on. Git pull. Let me make sure the tests pass. It is perhaps cached. I'm not sure. But yeah, if you look at the implementation here, in the I wrote a function compute cohort affinity. Earlier, if you recall, the cohort affinity was directly being fetched from the cohort addressing layer here. I moved it out to a function, compute cohort affinity, which takes the user features. It passes through a cohort addressing layer, which is a neural network. It outputs a value per cohort for each user. So for each row in batch, for each cohort, you have a affinity. Now there are two forms of regularization: the top K regularization, which essentially chooses the top items, and for makes your entire matrix 0, and for the specifically the top indices, it makes it 1. I've also added affordance in case you have more than one top K. Maybe your top K is 3, for instance. In that case, the value is 1 by 3, so that it sums up to 1. But pretending for a second that top K is 1, then 1 by top K will be 1. And so it will end up being 1 for the highest, for the cohort with the highest affinity per row in the batch. That is one regularization. And the other approach is the softmax, where we pass through a softmax layer with dim -1, ensuring that if you sum up all the values for each row in batch, it will be 1. Okay, so then you return this cohort affinity, and then you multiply it with the cohort embedding matrix, and then pass it through the DHE stack to get the user ID embeddings.